If it's not apparently obvious, we are really excited to have Jeff co-teaching the class this year. It's the first year that it's a joint class between Aero Astro and the Media Lab. And it is quite exciting to be able to have Jeff's time and just experience also teaching us about zero gravity and all of you as you prepare your projects. So thank you very much for co-teaching. And I'll just put this in as a little plug. We co-teach another class together, still TBD if you want to co-teach it in the spring, but we just taught operating in the lunar environment together in the spring of 2021. So hopefully that'll be another class that you guys could follow along with if you're interested in space exploration. I'm Ariel Ekbla. I'm the director of the Space Exploration Initiative. We were an organization birthed out of the Media Lab originally, but we now have a charter in which we are trying to support research across MIT. So the Space Exploration Initiative now supports annual projects from MIT Aero Astro, Earth and Planetary Sciences, Sloan, Mechanical Engineering, Art, Architecture, ACT, and we're always really excited to have a broad, kind of diverse group take the class. So if you come from a department that we haven't worked with before, we'd be thrilled to have you. So if I didn't list your department, don't feel like you're not welcome in the class. We're always really happy to have a good group. Hello to the folks who just joined us. We're just introducing the teaching team. So Joe Paradiso is on our call remote. Yeah, so just for everybody who just sat down, Joe Paradiso, instructor on the phone. Jeff Hoffman, instructor here. Myself, Ariel Ekbla, I'm the director of the Space Exploration Initiative. This is now the 4th year that we've taught this class. And I'd also like to introduce you to Sean Offinger, who is our head TA and course facilitator. He's also our mission integrator for the Space Exploration Initiative. So he's a great person to come to know because he will actually be guiding you throughout the life cycle of your project, not just for zero gravity, but if you get involved with us through this course, also for International Space Station missions, for suborbital flights, for some of our field work that we're going to do this next year, and then eventually we're hoping to be able to offer the community lunar surface payload opportunities as well. So Sean will continue to be your point of contact for all of that. So what we're going to do for class today is I'm first just going to do a short presentation about what the Space Exploration Initiative is, so you guys get a sense of the organization behind the class and some other opportunities available to you. Then we'll go over details for the course, so how to get admitted, the syllabus, any questions you guys have about projects, how do you actually confirm your flight slot in the spring, all of that. I'll then do a really quick overview about what is a parabolic flight in case you're wondering how does it work, how do you actually get a chance to get these beautiful moments of simulated microgravity at the top of the parabolic arc. And then I will pass the torch to Jeff and he's going to give us the first lecture of the term, probably around the 2nd hour. Welcome everyone to the Fall 2021 Zero Gravity Flight course. I am the director of the Space Initiative, as I mentioned before, and we are working on various projects, now about 40 different projects in our portfolio, for designing, prototyping, and building what we like to say, the artifacts of our science fiction space future. Our mission is to be grounded in the really rigorous technology, design, engineering, and art of MIT, but then try to take ideas for creating the human lived experience of space. This is why we really love working with Jeff and a bunch of other folks across departments at MIT, because if you are going to have a richly envisioned future of space exploration, you'll want lots of different perspectives. So it's fantastic that we have GSD here and IDM and Aero Astro and other departments because we really are a very interdisciplinary organization and the class is put on in that spirit. Our particular mission is threefold. So we're trying to do a lot of different activities that democratize access to space. How do we get backgrounds and fields and disciplines other than just traditional aerospace engineering and physics? I myself was trained in physics. How do we get more people engaged in the future of space? This is also a big focus for us on diversity, equity, and inclusion. How can we make sure that space is becoming more accessible and more representative of a broad swath of humanity? We like to say that we're trying to revolutionize the approach to space. Everybody does want to do this, but we, for a while, had the opportunity, especially based out of the kind of quirky part of the Media Lab, to think about projects that might not have gotten funded by NASA right away, that were maybe very creative, kind of on the edge of what would have been acceptable within the normal realm of space projects, and we love making space for that. We also work now on really core technology, so my own PhD was around self-assembling space satellites and electromechanical engineering, so we really try to make space for all of the different types of approaches to the next generation of space exploration technology. And We always like to say you're not a real space program if you're not launching into space. So we like to realize space exploration, and that we have a really core focus from our earliest days about getting you all opportunities to really deploy your work in a microgravity environment or actually in space. So we're not a design house. We do have a lot of designers and a lot of speculative work that happens, but we really favor projects that can be built, can be realized or tested as a prototype, and sent on a microgravity flight, a suborbital launch with Blue Origin, eventually an International Space Station mission, so actually time in orbit around our Earth, and now eventually to the lunar surface, and maybe beyond in the next decade. Who knows where we'll go from here. Our long-term North Star vision, because we are space nerds at MIT, is we love this notion from Star Trek of Starfleet Academy. And I really do think you've all landed at MIT. Congratulations to all of you, amazing students, and Harvard as well, like in this network of Cambridge. But yeah, we have this incredible set of organizations here in Cambridge, academic organizations, that really could be the foundation of a modern, real-life Starfleet Academy. When you think about the diversity of students, our mission, trying to have an ethical approach to the future of space exploration, but it's also where the space cadets went to learn and to be able to be, the beginning parts of this vision of exploring the cosmos. And so we're excited to try to contribute to that as part of MIT. If you're ever wondering who we are, this is a slide that just shows the team. And this team is really at your disposal. So we have a large staff team now, about 10 different people. Sean, for example, our mission integrator. We have designers, an art curator. We have really deeply technical electrical engineering and mechanical engineering support. And these are all people that can help support you in your projects. If you need a little bit of contract engineering, we pay for it. If you need a little bit of technical mentorship and advice about what is it like to prepare a mission for the International Space Station, we have a lot of mentors that can help walk you through what is it like to get a payload ready for that kind of big class environment. So we're also really delighted to have a fantastic faculty leadership team. So I'm the director of the initiative, but I report up to Damon Newman, who's now our director of the Media Lab, our new director this fall, Joe Paradiso, my former PhD advisor and a wonderful mentor, and Maria Zuber. And Maria Zuber, if you guys don't know that name, you should. She's an amazing woman at MIT. She's the vice president for research, and she really supervises most of the research that happens at MIT. A lot of it rolls up to her. She also supervises MIT Lincoln Laboratory, and thanks to her support of the initiative, we've really begun to serve more than just the Media Lab, as I mentioned before, so trying to make sure that we're working really well with other departments and now even across institutions. Here's a fun shot from our very first ever zero-G flight. You'll see a lot more of these photos as you go through the class. This is Annie Liu, an artist who flew with us in our very first year upside down. It's a great photo that was taken on the flight. And here's just kind of a sense of these other opportunities that I've mentioned as part of our launch pipeline. So sometimes projects really do go through this flow and they touch all of them. Sometimes projects start on zero-G and then jump to the International Space Station because they don't need the intermediate nature of the experience that the Blue Origin flights give, for example. And then sometimes biology projects in particular, if any of you guys are thinking about biology, don't even take the zero-G class because they need days of time for a biological system to respond in microgravity, and there are opportunities to just jump straight to the opportunity that makes the most sense for your payload. So if you have other friends that are considering, you can also let them know that we are flexible as long as the project is merited. To give you a sense of the kind of wild and wacky, but also interesting technology that has come out of this class, these are just a few of the projects that have flown. I have a whole other slide after this to show you more, but you can see it's many different categories of technology and design, food, astronaut biosensors, space architecture, zero-G exercise, all kinds of just very interesting. Really, it's reflected from all of your passions. It's what do you guys bring to the course. We'll talk a little bit more about this, but we typically accept students who come in with a project concept. It doesn't have to be fully baked because that's the whole point of the class. You'll continue to refine the idea. We do have one project that I'll talk about later that has already been proposed to us by an organization that would fund it. And so if you're coming in really interested in learning, but you're not sure what you want to work on, we do have one project this year that you might be able to match to. Just quickly, to give you a sense of what do we do outside of these flight opportunities, we do a ton of outreach. So we really believe in K-12 STEM education. We host a huge event at MIT every spring, except with COVID. So we actually haven't done it for 2 years now. But we host Beyond the Cradle, which you will now all get an invite to. we bring together 60 leading space visionaries, so CEOs of space companies, astronauts, scientists, but also Hollywood producers, science fiction authors, artists, because we just have this vision of this co-design for the future of space exploration. And with that, that's enough of a pitch on the SEI, which is what we affectionately refer to as the Space Exploration Initiative. And now we will actually get into some details about the course and how you'll all be admitted and consider the application and all of that. This is our course number, so I think most of you in here are registered, pre-registered or registered, but if you're not, this is what you need to register. This email alias is where you can reach us as the teaching team. It is the best way to reach us in that I will speak briefly for Jeff and just say I think both of our inboxes are a little slammed. So if you really want information about the class, Sean is also on this alias, and he's more likely to be able to either get our attention or get back to you quickly. So this is the best way to reach us. And then this is our website for the class. So we're not using Canvas right now unless we get made to. So for now, this is the main course website. It's just zero-gravity.pubpub.org, and I'll show it to you guys in a second. For admission, on the website, you'll find a link to the application form. We've also pasted this in emails that you may have all seen, promoting the class to your departments. It's due September 17th, so that's this Friday. However, you are more likely to be able to get a slot in the class the earlier you submit the application, because there's a lot of interest this year. We're kind of reviewing them on a rolling basis, and so we're saving slots in our mind as we come across really good projects. So you can certainly help us and help yourself by submitting it as soon as you are ready. We never want to make it due today or before today, because we want you all to be able to get the information you need if you're still thinking about how to submit. But it would be really helpful the sooner we can get it. And then what we promise you is in a single weekend, basically, if you can get it to us on Friday, we review it Friday afternoon and over the weekend, and we'll get you an answer by Monday the 20th, end of day. That way you know whether to come to the next class or not on the 21st, next Tuesday. We do ask that you only apply for the class if you have advisor approval. And the reason for that, this may not be applicable for everybody. I don't know exactly how GSD advisors work. But if you are a research graduate student at MIT and you have a PI, this class is a lot of work, and we tend to prefer that the PIs really have blessed you to take the class, that it's not a side project. If it is a side project, we also would ask you to float it by your PI and just make sure that they're okay with that as your arrangement. But we will ask you to send us an email from your advisor saying after you've been admitted to the class that they approved it. So let's not surprise them by having to do that only after we've admitted you to the class. The criteria for admission, what we really are looking for in the applications is you should be able to show us how you're using the unique affordances of this unusual environment. So if the project would be exactly the same in a gravity environment, then it'll be a little bit less interesting for this class. So really think about what is it about your project that's making use of microgravity or hypergravity. We'll talk a little bit more about that, but you'll actually get both environments as you go through the flight. This doesn't mean that it has to be a physical, mechanical project. We've done a lot of really amazing narrative art performance projects, but make sure that you're thinking about the impact of a microgravity environment on your project or hypergravity.
I have a question.
Mm-hmm.
Do they in the course of the flight do any lunar parabolic?
Yes.
And is lunar G allowed?
That is a great point. Yes, we do lunar G and Martian G. We typically only do 3 of those. So the main purpose of the flight is to look at microgravity environments, but Jeff's absolutely right. And we have had projects that managed to design themselves around an interest in taking data for lunar and Martian G as well. For example, we had a nanopore genetic sequencer fly through Maria Zuber's lab and Chris Carr, looking at future technology that might be sampling DNA or precursors to DNA on future planets. And they didn't know exactly what planetary gravity they would be operating in, so they actually really were interested in taking data across the lunar. That was Chris Carr's, yeah. It's a great experiment. You'll see some data from him later in this presentation. So yes, very good point. Lunar and Martian as well.
I have a question. If we build a prototype and test in the zero G environment, how much time duration do we have?
Great question. So we'll definitely get into this more when I show you guys the flight path, but the short answer is you get 15 to 20 seconds of decent microgravity on each parabola, and you'll get at least 17 of those. So it's a little bit like a roller coaster in the sky. Sometimes the pilots do a better job, and you get cleaner micro-G without these other vectors of motion that are kind of coming in if the plane's rolling or tipping. So it can be a little bit shorter or a little bit longer depending on the pilot's skill.
And
Do you want to
we'll probably talk about it, but there are different ways of designing your experiments. You can be attached to the airplane, in which case you're subject to whatever zero-G the airplane can do.
Yeah.
For some experiments, you can actually just free float them.
Yeah.
Then you run the risk that they're going to bump into the ceiling or the
Or your
wall.
friend.
But that will give you a pure micro-G for
Yes.
however much time
You're in
it's
free fall.
floating.
Yeah.
So Ariel will go into that in more detail, but yeah, you have to be aware of the limitations of the zero-G experience. It's not always totally zero-G.
Yes.
It also depends on winds and
Yes.
things like that, how well they can control the plane.
Yeah.
Right, because it's completely hand flown, and
Yeah.
they're looking at like a floating rubber ducky to see if they're in microgravity or not, and they do have some more complex instrumentation for the lunar and Martian, but we can also hit any other intermediate.
We can hit
gravity
Europa.
level that you want, but we primarily focus on microgravity.
Yeah, exactly. So in addition to that first criterion of really making use of this unique environment for the flight, we expect students to be able to commit to a pretty serious follow-up. So if you're a research student in MIT or Harvard, this means try to design the experiment such that you could maybe at least do a conference paper. It's very rare to be able to get enough data, especially out of your first flight, to do a journal paper. So we're not expecting crazy results or great success. It's often very exploratory. But being able to at least from the beginning aim towards something that's more rigorous is a great way to make sure that your project becomes more rigorous. If that's not applicable for your particular project, then a really well-produced video, a very nice blog post, something that really says, I took advantage of the flight and it wasn't just a one-time fun roller coaster. I'm really going to progress with this project and use this towards my portfolio or my career or my thesis. So we like to see students take it really seriously. We also expect the applications to be at least mostly rigorously researched, and that NASA, as you might imagine, has done lots and lots of experiments on parabolic flights. Organizations like MIT and other academic groups have also now really explored the parameter space of a lot of things that you can do. It doesn't mean that there's not tons of novel ideas still out there. There are. But if you've done something, it would be great for you to, or if you're proposing to do something that maybe NASA's touched on or another group has partially explored, give us a citation in your application. Let us know that you're at least aware of the prior art or the prior literature review that might touch on aspects of your idea. The areas that we typically accept projects in are research, so this can be any technical field, outreach. So we've done some projects just simply around engaging youth and students or a broader and more diverse group of humanity in the flight, and then also statement, narrative, performance, or art pieces. Course requirements. The vast majority of your grade as graduate students for this class is based on your project. So 50% is the final. We use NASA language here for a CDR, which is a critical design review at the end of the class, and then your midterm is a PDR, or a preliminary design review. This is much more condensed than you would ever do it in the real world. Nobody really expects you to usually do a PDR and a CDR within 2 months of each other, but we try to introduce this framework to you through the class. And 70% of your grade is just basically, are you meeting our rubrics? And we're very explicit about what we look for. So we'll give you a very clear template about how to pass the PDR and the CDR. The rest of the class is informal in that we don't, especially since you're graduate students and most people are not here for the grade and most people are here for the research expertise, we're not particularly active about giving you guys grades for your project paces or even grading your P-sets. We mostly just expect you guys to do it for your own learning and for completion, but these are some of the other things that we will introduce you to through the class. So we expect everybody to maintain a project page. It's kind of like a blog post of your prototyping experience, your progression of the project. We do expect you to attend the recitations that we schedule unless you can show us that you've already mastered the skill. And we do this because this class, obviously you come in with such varying backgrounds. We teach CAD, so computer-aided design. We teach electronics, basic embedded electronics. We teach some aspects of design aesthetic, lighting for your project. If you're an expert in one of those areas, then you interface with Sean and you basically just say, send Sean an example from your portfolio or from your research work that says, I know how to play with SolidWorks. I don't need to be taught how to do SolidWorks, and then Sean can exempt you from the recitation. We are not in any way trying to make extra work for you in the class, so just let us know what skills you're interested in, and then attend those recitations. We do P-sets associated with the recitation, so if you're learning CAD, we'll have a CAD P-set associated with that. We do love it. Today we're mostly lecturing at you, but in general, we would really love to have good class participation and interesting dialogue, so please feel free to speak up. And then obviously, we can't twist your arm and make you show up for the flight, which is in next May after the class, but I don't think we've ever had a student take the class and not show up for the flight. So the kind of the deal that you're making with us is that you'll continue to take the project seriously even through next spring with whatever kind of finalization tasks you might need to do as we prepare to all fly together in May. Sorry that the text is kind of small here. I don't know if you guys can see it, but I do just want to point out how many resources we have at your disposal for this class. So there are the three of us as your course instructors. Sean, an amazing resource, as I mentioned before, also our mission integrator. We have several alumni and staff members from the Space Exploration Initiative who will come in as kind of one-off TAs that you'll meet. We have our staff engineers, if you guys need help scoping some of the technical aspects of the project. And then we also bring in, most days, a really interesting guest lecture, including a panel of astronauts at the end of the year who are your final jury for your project. So kind of like an architecture crit. We have a panel of astronauts that come in and give you feedback. And Jeff has participated on this several times. And then you'll get to meet a few others as we get that scheduled in December. For project and pre-flight support, the recitations I mentioned, a big part of this class is filling out this kind of large document called the RPP. You'll hear us talk about that a lot. The RPP is the Research Program Package. It's kind of like
they changed the name this year.
Oh, did they really?
Project Integration Package, I think.
Project PIP?
But if you hear RPP, that's what we're talking about.
Yes, RPP or PIP is basically just like the safety data submittal. So if any of you have worked with a technical engineering project before, especially for NASA or another group, this is where you declare all of the pieces, kind of down to every last screw and washer and O-ring of your project. You'll be asked to do some basic mechanical design calculations to show that if you're bolting something to the plane, that it can withstand a certain amount of force. If that's not your expertise area, that's okay. We have a lot of people that will help you fill out these elements of the package. Office hours on request. We've never done standing office hours because it really sucks for us if we're just sitting around and nobody comes. But if you do need to talk with any of us, please reach out, again, to that Zero Gravity mailing alias, which would be great. And then guidance.
I'm sorry,
Please.
you finished.
No, please.
For the VR-based projects, not other human-based projects, is there a need to have both COE's approval, and do we typically have support from the research team to assist with COEs?
Yes and yes. So that's a great point actually to raise right here, which is another resource. I should add that to the slide for next year. Thank you, Paris. So COEs, if anybody hasn't heard of this before, is what MIT basically calls our institutional review board for human subjects testing. It might seem silly, but it's not, in that this class, even if you're testing something only on yourself, you still need to go through COEs. They will almost certainly give you an exemption, which means you do still have to kind of fill out their fields of information that they want from you, but they rarely really make you go through, in this class, a full-on COEs process. Sometimes for human suit work, like Rachel Belisle last year in the Human Systems Lab, I think she did have to do a little bit more of an extensive COEs. But we are happy to help you interface with COEs. We have a designated class contact for COEs, so if you do think you're going to need to submit something, definitely loop us in. I can introduce you to Michael Keohane, who's wonderful. He's very familiar with the zero-G flights, and he'll help you navigate whether you need a full COEs submission, an exemption, or if you're nervous and you just want to check with him, he might even say, no, this you don't have to go through COEs. If you, the human, are flying, but the thing you're testing doesn't really have to do with your body, you're just the operator, you do not need to do COEs. You only need to do CUIs if you're taking data about yourself or others on the flight as a human subject. Does that make sense? Great. All right, and then on the financial side and material support, we are probably going to supply, again this year, kind of a getting started kit. So we'll buy everybody like a basic Arduino or a Raspberry Pi, a little bit of electronics, astronaut ice cream for fun. We like put some surprises in every year just because. We will reimburse every project team a certain amount. It depends on how many project teams we admit into the course, but we do have course funding, and usually this works out somewhere between like $200 and $400 per team. So this can be enough to buy some of the 80-20 hardware if you're going to build yourself a box, to contain your experiment. This can go towards the actual like material that you might want to buy that you're building on the inside. It can go towards GoPros if you want to document your performance. It can go towards essentially whatever you need it to go towards, and we do it on a reimbursement basis, right? So in the past, we've tried to have Sean and Al order direct, which I think we would still like to be able to do. So if you can hold off, work with our admin and Sean to get it purchased for you, then you don't have to put up your own money for it. But if you also have just bought stuff.
Sales tax.
And avoid sales tax. Yes. As if MIT buys it for you, avoid sales tax. And also if you buy it for yourself and you get reimbursed, we can't reimburse you for the sales tax. So anyway, nuances to discuss later, but Sean and Al, my admin, will help you guys all get your purchases done. And then we also have now a very large supply of boxes and hardware and kind of like infrastructure from past projects that people have not wanted to keep around their lab, so they've donated it back to us, and then we make that available every year. A big one that's really popular is if you have a big box that you want to attach to the flight, to the plane, in between the box and the plane, you have to put a base plate of like 1/2-inch thick aluminum, and then you have to mount to that, and nobody wants to have to buy their own big base plate. Just have a chunk of aluminum and machine it. So we have tons of base plates, for example. So as you're getting, this will be more in like the November, December timeframe, but as you're really finalizing, if it's a hardware project, definitely we'll be reaching out, we'll be letting you guys know a list, kind of like a bill of materials of what we have available for you. Okay, so for the flight details, we haven't pinned down the exact date in May yet, but we do try to be very cognizant of having it not directly conflict with MIT Finals Week. We try to usually have it after finals and before graduation, or in the week right before finals, so we'll keep you posted. We fly out of Peace, New Hampshire, which is about an hour north. It's a very small airport. The flight is usually about an hour and a half. Sometimes it's 2 hours, but actually the airspace that we have in Peace, we only take about 20 minutes to get up to cruise, and then we're in the airspace where they want to start the parabola, so it's actually an even shorter flight overall. And the biggest detail to kind of keep in your mind, especially if you're working on a multi-person project, at this point in the course, we only guarantee 1 flyer spot per project. So try to avoid designing a new project for the first year that requires multiple people to operate it, because we can only guarantee that you'll be able to fly with 1 operator. Now that said, we always end up having waitlist slots. And so we have been able to, in past years, usually in April, say, you let us know last year that you'd be really interested in having a second if you could, and luckily we've had a slot open up and you can bring a buddy. And we always try to honor those requests when we get them, but because we can't guarantee it, we recommend you to preferentially design your project around a single operator. One other thought about that, if you are the main operator, but you might be doing really interesting maneuvers with your body, or like Rachel Belisle last year who needed to get into a suit and really needed help, we do have flight crew that can help you. So while we might not be able to guarantee you a second flyer like your friends or your project coordinators, we will make sure that you have a safe and fully kind of empowered opportunity to fly. So there'll be essentially really, really well-trained flight attendants that are flying with us that can help you get into a suit or get into a performance or whatever it is that you might need help with.
Yeah, and they're from the company.
They're from Zero-G.
So they've flown thousands of times.
Yeah, and we usually fly with some veteran SEI flyers as well. I'm hoping Jeff will be flying, so you might also be able to have the help of an astronaut or the help of Sean, somebody who's flown before and will be able to support the flight. Okay, costs and planning, if you're trying to get a budget to your PI for this, for example, we cover everything associated with the flight. So there's no hidden fees or anything like that. So we pay for your flight ticket, access to the hangar. We pay for the bus to get everybody up to the facility. What we don't cover are costs above and beyond like the $300 or $400 that we're able to reimburse you for. We don't fully pay for the cost of your project, and that's because most of the students that take this class are in a sponsored lab at MIT. For GSD, let me know if this causes any confusion, or for IDM, but if you want to build a project and you think it's going to cost you more than about $400 to do it, then you want to make sure that you've identified some other sources of funding. This is also where that PI approval comes in. We've seen typical projects be anywhere between about $500 and $1,000. $1,000 is more for like the really technical projects, like if you have fancy optics, or if you're doing maybe a propulsion test, or things that just like the individual hardware pieces cost more. So just to kind of keep that in mind. And then if you decide, you want to get up to Peace, New Hampshire on your own in an Uber or something like that, then those kind of logistics costs will be on you. Shipping costs for getting things that you need shipped to the lab, that would be on you, etc. Some caveats for joining the flight: full, unambiguous advisor approval if you have an advisor, if this is applicable. After you're admitted to the class next week, we'll pass around a document that basically says these are all of kind of your responsibilities as a flight project creator, and we'll ask you to sign. There's also MIT liability waivers. If you're not an active MIT student, if you're coming from Harvard, we'll have to have you sign a liability waiver that basically says you're not going to sue MIT for coming on the flight. Research cost, yes.
Quick question.
Thank you.
Does the advisor kind of approving your registration, does that count as approval, or is it like a separate do we have to separately ask for explicit approval again?
Yeah, we generally ask for an advisor just to shoot us an email that says, yes, I approve the student taking this course, so that they know about kind of the costs associated and the time involved. If you have gotten approval from your advisor in an email thread, you can also just forward that to us. They don't have to send us a fresh email, but we do ask for one additional confirmation level. So we just talked about this, but research costs, logistics costs not covered by the Media Lab. We do typically see that projects, although we pass you at the end of December, there are often finalization steps that you might still be taking after the end of this class. It's really up to you whether you want to take this fall and absolutely finish your project so that it could be ready to fly in December, or if you get it far enough that we'll pass you for the project, but you're still maybe tweaking the code, for example, through next year. So expect to spend a little bit of time on this in IAP in the spring semester. You do need to be able to be medically cleared to fly. This has never been a blocker for anyone. So if you're worried, you can always come talk to me. Stephen Hawking, for example, was able to fly, so it's really usually not a blocker, but Zero-G does ask you to fill out a medical form before you fly that just has some basic things like, are you likely to have a heart attack in the middle of the flight, kind of things like that, really major things. You should be ready for your research to be shared publicly, and this is because we have up to 14 or 15 projects all together on the flight, which means there's really no way, with tons of GoPros around, people taking pictures on their phone, and we pay for a videographer to come, there's really no way to expect to keep your research private, so it's going to show up in the background of somebody's shot. And we like to talk about the research. We really, especially to get people excited about this class and the Space Initiative, we usually use this as an opportunity to really promote your projects. We will never talk about your project to the press without your willingness, and especially not without your PI's willingness. So we don't go out and shop the projects around. But this is not probably the best venue for really IP-sensitive research, if you're working on a patent or it hasn't been submitted yet. So the final steps to be able to fly require Zero-G Corp to sign off on your final RPP, and to sign off on a final safety inspection that you actually do in person the day or two before the flight. This is something that we, as your champions, will defend you. So if any weird questions come up, we'll really, help you through the navigation process. We have had one project in all 4 years that we've taught the class where they declared something in their RPP. Their project showed up the next day for the inspection. It did not match their RPP, and Zero-G denied them the right to fly. And it was really the responsibility of that student. So
it was a safety critical item.
It was a safety critical item. So the lesson here is just to make sure that when you submit your RPP in the fall, you're really submitting it to us internally and we give you feedback on it. The final RPP, the declaration of your project, is usually not due until about 2 months prior to flight. But when we get to that point in the spring, you do need to fly as you've declared. So that's something to really keep in mind. We can only intervene up to a certain point if your project shows up and it's not what you promised it was going to be. We also ask you guys not to diverge materially over the course of the spring after you've left the class from whatever it is that we approved in December. Also, if we admit you with a certain project concept, now in September, if you want to completely pivot to a completely new idea sometime between September and December, we might ask you to kind of go through an application process again, and that we're really admitting a cohort of projects with balanced representation of different types of ideas, art, research, design, etc. So we ask you not to change too much after you've been admitted into the class with a particular concept. What you can expect for your project timeline for this fall, we usually give you all of September, which now that we're starting just with the way that classes work this time around, it's actually not that much more of the month left, but September is for idea generation and refinement. We expect you to really be kind of prototyping hot and heavy through October and November. We like to see some level of testing and assembly in December, so you really should have something already assembled because you're going to be asked to demo it for some astronauts at the end of the course. The critical design review and the RPP submission are essentially whatever the last day that MIT allows us to request the submission of assignments. That's the last day, so it's kind of like right around the final period. Project finalization and tweaks into the spring. Final RPP submissions usually around March, so that's when it's kind of like the point of no return for changing things about your project.
It says mid-December here, but the last day of classes is the 9th of December. And that usually is the last time
is the last
that
day.
we can ask for people to turn things in. So
yeah,
it's
a little
really
early
at
this
the
year.
end of the first week of December, not the middle of December.
Yeah. So we'll spend a lot of time with the teams in November getting your RPPs ready so that you have a chance to be ready to submit them. So yeah, it is a little bit of a condensed semester this year. And then the flight in May. I'm just going to quickly mention the extra project that we have this year. So this is submitted by a team called Astro Access. It is a nonprofit organization that's focused on improving accessibility to spaceflight, particularly for people who are disabled. And so they are going to be flying their own flight in October of this year. And then also, we're going to try to match them with one of you as a graduate student who would be interested in working with them for your project. So whichever graduate student matches with them, one of the benefits is you'll get to fly twice. Get to kind of an extra flight. There's a focus on sight, hearing, and mobility-based disabilities. So if you have any ideas about prosthetics or haptic feedback or proprioception control, which is a topic we'll get more into, and if you think you might be interested in matching with this project, then definitely let Sean know. I think we have an opportunity in the application for you guys to identify this as a project match if you would like to work with them. The other stipulation for this is that their team will be on campus with some disabled advisors. And that's September 20th, 21st, and 22nd, so it's next week. So if you already know you're really interested in this project, then that would be a great kind of 3-day workshop to attend. It's only 2 hours each day in the afternoon. So if you're looking for the details on that, reach out to Sean. Generally, though, students enjoy the freedom of coming to the class and submitting your own project idea. So we definitely encourage you to come in with your own desire for what you'd like to fly. And after this class, we encourage you to stay if you're looking to team up with other people. Yes, Michelle, and then.
So in the SEI email, you mentioned like volunteers for this project. Is
Yes.
it something different?
That's the same one. Yep.
No, but so like could I be a volunteer through the SEI, but do my own project for this course?
Yes, absolutely. So you might not get to, if you don't take this as your main project for the course, you probably won't get to fly twice, but you can absolutely still volunteer to join the design session if you're interested in participating, and then still do your own separate project for the class. Yeah, they're not totally coupled.
Great.
So if you fly on October 17th, does that mean your project needs to be What's that initial flight essentially for?
Great question. So that is like a really, really early prototype flight. So next week, over those 3 days, it's almost like a little mini hackathon. So the idea is that we're going to come away with something. It could be very simple, maybe even no electronics, just kind of like a test object. And then that would be what would fly in October. And then you would have the chance to refine that, also working with the Astro Access team all the way through May and fly again with a more fully fleshed project in May. Okay, so this is the course website up here. I'll just give a quick overview. So you can find most of the resources that you need for the course here. You can also find last year's content and multiple prior years' content if you want to see and watch lectures ahead of time, or if you want to see just kind of what we've taught in the past. But under your fall 2021 course is information you'll want. Here on the overview page, it's really just kind of recapitulating a lot of what we just discussed, but we embed the syllabus. And we do ask you to keep an eye on the syllabus each week because we update it as a live document as we go through the class, which means that readings for the following week will be posted on the syllabus here. We also send out emails to remind you guys of the readings for each week. What I'd like to call out just really quickly are this table here. So here again, you can see 70% of the grade for the class. Not that I think graduate students should really care too much about grades, just really focus on your project and what you're getting out of it. But most of the grade percentage here is associated with the project. And the way that we run the syllabus is, except for today, each day is either tagged with Parabolic Flight Prep in green, which means that segment of the class is very much focused on practical logistics information, getting you guys ready to fly your project. And then we alternate with space exploration lenses. So this tends to be when we have, outside of MIT people come in, or even just really cool people around MIT, come in and give you a guest lecture about what are they doing in space exploration. And we love kind of interleaving these different interests throughout the course. So that's how you'll know each day whether it's more practical logistics focused for parabolic flight, or if it's more about different ideas to engage with about the future of space exploration. Any questions about syllabus? Anything so far? Any?
Question on
Yeah.
the recitations.
Mhm.
When will those be? Are they always going to be at the same time outside of class, or will it vary?
The recitations, because it will tend to be a different subset of you each week who needs that particular skill, we tend to schedule them on an ad hoc basis. Sean will reach out, usually do like a doodle or a when to meet to get you guys coordinated. If the whole class can settle on a weekly time, we'd be happy to do that, but it tends to be quite difficult with everybody's schedule, so we kind of do it on an ad hoc basis. Okay, just gonna play a couple of videos here to show you guys what it has looked like for a couple cohorts in the past in 2017 and 2019. Whoa. So this is kind of a similar layout to what you guys will experience. The entire flight is filled with researchers and experiments. Here's an example of a crew member helping Xing achieve a maneuver that was going to be a little bit complicated for her body to do by itself. This is a multimedia example of one of the outreach projects that was actually really mostly for K through 12. You can see that it's quite crowded inside the plane. So particularly if you're thinking about a narrative or performance piece and you really want to get a beautiful camera shot or a nice angle, then it's worth thinking about how to set up your area with a backdrop or the right lighting or something to be able to protect a view that you need, because it is kind of a chaotic environment. What these videos don't quite communicate is also how loud it is. You're inside of a plane where most of the things that absorb sound, like the seats, have been ripped out. So it can be quite loud. So you're often kind of yelling across the plane to talk to other people. There's Annie, actually, that shot that you guys saw earlier of the artist who was upside down. There are certain categories of materials that are really amazing to play with in zero-G, one of which is fluids, and I think we're going to get to see a little demonstration later. But anything with fluids is yields really quite interesting effects in zero-G. That's Maria Zuber, VP for research, having a great time on one of our flights. And that's the whole team that flew. And now I'll play one more video. You guys can see kind of another sampling of what flies. Forgive us for the cutesy music on both flights. So that's the ERG, one of those exercise devices that just got flashed up. This is a prosthetic tail, testing human body's ability to work in concert with a tail that might eventually grip onto things on the International Space Station. Here's an example of one of the really interesting art-focused projects of sculpture, live sculpture in zero-G. I think we have some space-enabled folks here today. So this is an example of a space-enabled project that's flown, centrifuge wax casting. Here's another example of telemetron. So this is a nice example of if you fly with us once, and you really take it seriously and you do a nice job with the project, we often let people fly again the next year without having to take the class again. So Telemetron, Rachel Bellisle's suit, for example, these are projects that we're going to allow to fly multiple times. Because we do want you guys to really be able to get, especially if it's a thesis project, we want you to be able to get longitudinal data and build up enough data for a journal paper eventually. We sometimes get approval to fly bugs and other weird things. There's a hazards kind of control process for all of that, but we've flown some very unusual, odd objects, including kombucha and bacterial cellulose and some very unusual things. And there you go. So now, oh yeah, please.
What are the different suit colors mean?
It's actually quite funny. So if you see green suits, those are child suits, but I wear a child suit because it fits my body better. So it's really just about sizing. Yeah. There's nothing special about the green versus the blue. Yeah.
Do you get, like, I saw someone who was doing like an art project where like a silver suit?
Yes. So this is something that we can't offer to the entire class because zero-G typically only approves it for maybe 1 to 3 flyers every year. But if you're doing something that's particularly on the performance side, zero-G will let you build your own custom suit or sew your own custom suit. The reason that they say no to more of that is actually very annoying. It's a branding reason. They want all of us with their zero-G logo floating around. So that's why we're a little bit limited. But yes, sometimes you can get approval for a custom suit, which is quite fun. It certainly does add to their experience of the flight.
I'm going to wear my flight suit.
Amazing. Oh, I like it. Yes. No one will say no to you for that, Jeff.
It's like even better branding.
It is even better branding, yes. Okay, so for the last few minutes here before I turn it over to Jeff, we're just going to do a few slides that give you more information about what a parabolic flight actually is. One of the things to keep in mind when I'll pull this slide up. When we talk about zero gravity flights, the better technical term is actually microgravity. So you'll hear a lot of people toss those two around, but the important thing for us all to understand is it's not like we flipped a switch in the universe. We're not turning gravity off. What's happening when you're in the plane and it noses over at the top of that parabolic arc is you are in free fall. So you are falling in the sky, and to Jeff's point earlier, as long as you're not tethered to the plane that might be having a little bit of a pitch or a yaw or a roll, you'll actually have really pretty pure free fall and a good level of microgravity, okay? This is also what's happening on the International Space Station, right? So there's gravity between all objects in the universe, as Newton's law tells us, but when you're in the ISS and you're seeing the astronauts floating continuously, it's because they're in continuous free fall around the Earth in orbit, okay? Now what you see here is happening. The plane starts off straight and level. At the beginning of each parabola, it takes a really steep climb, And this is where your body feels about 1.8 G. So it's quite interesting in that you're usually laying down flat with your head flat, aligned along the fuselage of the plane for your first few parabolas. And if you go to lift your arms, it's like twice your weight almost. So it's quite an interesting feeling for the body. They usually climb between 45 degrees and 47 degrees. They nose over, and at the top, just before they get to the top, they'll call out a command, which is nosing over so that you can begin to prepare your experiment if you have a lot of different tasks that you have to do to get your apparatus ready right before 0G starts. And then they'll also call at the end of this, where's my mouse, microgravity period, they'll call feet down, coming out, because you might be surprised just how far up against the top of the fuselage you floated. And as gravity returns, really as you enter this 2G pullout, they don't want you to fall down on your head. So they'll tell you to orient your feet first, feet down, coming out means we're coming out of the microgravity portion. Now this arc is repeated a minimum of 20 times for our flights. We usually fly, what is it, Sean? We fly 2 lunars, or 1 lunar and 2 Martian.
We've 2 Martian, then 2 lunar, then the rest micro.
I think we start with lunar because we start with Martian, and that's right, and then go into micro. Ease into it, yeah. So you'll feel Martian first, which is fun. You can do push-ups much more easily. You can kind of bound, and then you feel lunar, and it's really quite strange, and your brain is starting to really understand this is about to be a mind-blowing experience.
In lunar gravity, I can jump up, do a full flip in the air,
and come back down.
Seriously, I mean,
it's true.
Like an acrobat.
Yeah.
You things that you never thought were possible, but you'll only get 2 of them. So
yes.
Think about what you want to do beforehand.
Yes, exactly. Yeah, it's like on a trampoline. It's remarkable, but there's no bounce to your step. It's just being able to have that freedom to move. And then for the remaining 17 parabolas, we typically do 17 straight 0G. Now when I say straight, that means that we're not switching gravities again, but in between every 5 parabolas, we typically take a short break, and that's because the plane is probably turning around. So this is an example of the airspace. Now it's only showing a single parabola. Imagine several of those in series. But the plane is taking up, linear space as it's flying, and we are bounded in the air to a certain amount of flight space, and that's because they don't want us interfering with other planes in the jet stream. And I suspect, although I don't know, I never asked my dad, who was a pilot flying the jet stream, if he's seen another plane, going up and down, like it's out of control. But so we do have bounded airspace, so that's an interesting thing. Was there a question in the back? Did you have a question?
Yeah, so my project, or my proposed project, is on Martian gravity.
Mm-hmm.
So I was wondering if it's possible to request maybe more parabolas, or maybe even 1 more parabola, or is that just not possible at all?
It's certainly possible to request. You should put it in your application when you apply, and if there's at least a few other students that are interested, then we can always consider maybe doing up to 5, like up to a larger set. Eventually, with increased funding, there's also an opportunity to expand the flight that we fly from 20 to 25 and try to add additional parabolas. So absolutely make that request, and we'll do our best to accommodate it, but no promises, and that the typical flight is only 1 or 2. So if you guys do know that for your research going forward, maybe after this introductory flight, you would really like to do a flight that has a lot of lunar or has a lot of Martian, then one of the services that we try to provide as you guys exit the class is we help you, if you're interested, apply to the NASA Tech Flights Ready solicitation, which usually comes out in the spring. And that's an opportunity to custom tailor a flight with NASA. You have to win the grant, but if you win the grant, NASA pays for you to go on another series of flights, typically 2 flights in a single week, and they fly up to 30 parabolas. So we're also very happy to help people kind of enter that game of applying for NASA grants.
Just yourself.
So interestingly, it's you and typically several other academic institutions like Purdue and Georgia Tech. You kind of divvy up the flight, but they don't cram it quite as full as we do. So you actually get a full 12-foot section, 10 to 12-foot section of the plane to yourself as the project. And you can bring more people with you. So it's a really great way to kind of level up after this initial class if you'd like to get really good research results, get some more flights under your belt, and tell NASA that they will happily fly as long as they can work it out with the other researchers as well. More Martian or more lunar. Okay. case you're interested in who in the world provides this experience, the group that we fly with is the US-based option. It is strangely a little bit of a monopoly. It's the 0G, the weightless experience. There's a group in France out of KNAS, very closely related to KNAS, so they're French space agency, Novaspace, and then Roscosmos. And David Newman, who you might hear from later in the class, actually has a lot of experience flying on the Russian side. And they fly much larger aircraft. So the interior volume of the open chamber is significantly larger, meaning you can fall from much higher heights. So sometimes you'll actually see nets set up in videos of old Roscosmos 0G flights.
0G uses an old 727.
Mm-hmm. Yep, and here it is. 0G uses a Boeing 727. It is quite old. We learned, 1976, because my dad was in college. However, it goes through a C check much more regularly than a typical plane. So a C check is when you gut the plane, you take everything out really, and you completely reassemble, test the engines, test the inside avionics system. So it is a very well-maintained old plane. So in some ways it's flight heritage, you know. Even before the 727, for anybody who's a plane buff, this is what NASA used to fly these 0G flights with, not in this configuration. This is showing a refueling jet, but the KC-135, the big plane here, has also been used in the history of the 0G flight program, microgravity flight program.
That's what I have most of my 0G on.
Nice, KC-135. That's great. These are just some fun shots of the in-flight experience. This is Nicole Loulier with a musical instrument designed to only be able to play in microgravity, so it does not make the same nature or quality of sound in a regular gravity environment. This is Joe Paradiso, one of our instructors for the class, attempting to do a meditation pose, like a proper floating levitation. This is Annie, you guys saw her earlier, and this is not us. This is an example of what we don't get to do. So this is Richard Branson on like a party flight with George Whitesides, who is actually the head of Astro Access. So he's one of the founders now of that disability-focused opening access nonprofit that I mentioned. But because we have so many projects usually in the foreground, we typically don't do the Superman maneuver. Mm-hmm. However, if you get a chance to go on a fun flight, you can also do some other fun things. And typically at the end of our flights, you can ask a 0G crew member to come over and they'll help you do flips and somersaults if you'd like to experience that. Some historical highlights. This is the Mercury 7, two members of the Mercury 7 crew in their silver jumpsuits doing early tests. This is in the really early days of the space program, trying to understand what would happen to human physiology, proprioception, our ability to orient ourselves in this lack of a gravity vector when so much of our eustachian tubes and vestibular system is based on sensing a gravity vector. This is a photo of me from when I was an undergrad. NASA used to support undergraduates to go on 0G flights. This is where I first got my taste of 0G and kind of got the bug for space. This is Stephen Hawking flying on a flight several years ago. And this is Anusha Ansari, who was one of the first ever private space flyers. So she had an opportunity to go up to the International Space Station outside of the main astronaut corps. You may have heard that parabolic flights, 0G flights, are affectionately known as vomit comets. We take a lot of precaution to make sure that everybody stays comfortable. It's certainly no worse than a roller coaster. I personally hate roller coasters, and I love the 0G flights. There are many ways to mitigate the kind of cognitive dissonance that tends to cause people to get sick. So you're seeing almost straight and level flight even as you're free falling. You're seeing the fuselage on the inside, but your inner ear system is really sensing a lot of kind of strange maneuvers. And you can take scopolamine, which is it's a prescription required medication. That's what we usually recommend to people. You can take Dramamine or other over-the-counter medications to reduce your likelihood of feeling a little bit of nausea. Some people are totally fine. We generally recommend not risking it on your first flight and just take something to make sure that you have almost just the calm of knowing that you've addressed it. And the only folks that have ever had really like a bad time on the flight were if they were doing a VR experiment and they were kind of on and off with the VR while also sensing this and maybe didn't give themselves enough time to calibrate for the first few parabolas. So we'll talk about this a lot more. The vast majority of people who fly have a fantastic time. And we have now a little bit of a kind of low data set heuristic that Sean and I have figured out over the years about what can help you have a better time on the flight. And Jeff and others can also really speak to this.
Typically, I mean, Zero G flies tourists.
Yes.
They don't want people coming back saying,
Puking.
oh, I got sick, it was terrible.
Right.
Typically, if you limit to about 20 parabolas, very few people have a problem, even
Yes.
if they're not medicated.
Yeah.
You know, on NASA flights, sometimes we've done 40, 50 parabolas, that's work. And,
Yeah.
and after 20, it can start to get to you. And you know, don't go up there in your first couple of parabolas and start spinning around.
Don't overdo it.
Yeah, but basically, like I say, Zero G has designed their, and also you get the 5 minutes of rest when you turn around. They have designed it so that people don't get sick.
Mm-hmm. Yes. And you guys will get that type of flight. We're going to get more like the tourist flight that's not quite as long or as intense as the NASA flights. I'm not going to go too far into this slide because this is going to be a paper that we assign for you all to read, but just to let you know that there is data out there about the quality of the microgravity. So if you're looking to design a flight that's going to have to be bolted to the plane, meaning you are going to pick up on some of those fluctuations and you want to know what is the quality of the microgravity parabolas that you're getting, this is a great paper that was published by Christopher Carr, one of our veteran flyers, and it actually made it into Nature Microgravity, which is a nice thing for you all to put in the back of your minds, that it is still such an interesting opportunity and relatively rare to get to do good research on zero-G flights that there sometimes is an opportunity to get a really fantastic publication, even just out of 1 or 2 flights. This is what the RPP, or now according to Sean, the PIP, looks like. So you'll see a lot of this document. The homework for next time is to read this, so we'll be emailing it out. I know it might be a little bit much to ask. You guys don't know if you're admitted into the class yet, but it's certainly worth a scan through. Then you'll be writing up your experiment in this RPP format. Because we find this form to just be a real pain in the ass, pardon my French, we build you guys a template that you can use to fill it out, matches it. And then the third part is the in-person inspection, which you guys won't have to do until May of next year. So, assignments for next class before I pass the baton to Jeff. Complete the application process, so get that form in by as soon as you can, no later than Friday. Read the first 20 pages of the RPP, which we will send out, which gives you a lot of really great context about the nature of the flight. Try to make sure that you can go in and create a PubPub account. So if you go to the course website, you'll be able to see an obvious place up in the upper right-hand corner to sign up and make yourself an account, because that's what you'll use for your project pages. And if you're pretty serious about taking the class, especially if you've already talked to us and it sounds like your application is kind of pre-reviewed and you know that you're really going to take it, then start communicating with Sean about the first recitation and whether you would like to take the CAD and do the PSET, or whether you think you can exempt yourself out of it, that you're quite comfortable with CAD. And with that, are there any questions while we get Jeff set up here? I'm going to give you the microphone too. Yep.
You said it will be accepted, applications will be accepted on a rolling basis, but should we expect to hear back sooner than the 20th, or is that when we'll all hear back?
I can't promise when you might hear back. We are kind of reviewing them on a rolling basis, so we very well might get back to you beforehand, but I can't promise when exactly that is. You will hear back no later than the 20th end of the day.
So the data for the prototypes is, and when we bring them in, will we have a space to kind of work on them, or is there no more space, or is working on everything in our own labs and then we just bring them?
Mostly the latter. So the class is typically taken by folks who either are like in the Media Lab, in Aero Astra, or somewhere like GSD where you guys have workspace available to you. When we have the PDR, so the midterm, and then the CDR at the final, we do ask you to bring your projects in for demos, but usually you can work on it at home or like wherever else you have prototyping space. We do offer, every year we try, for anybody who needs to be shop trained and needs a little bit more support for some prototyping space, we do get people shop trained through the Media Lab. So you get to use a really amazing world-class machine shop downstairs if you need it, if you don't have that through your own department.